Welcome back. Let's go over the solutions for the previous assessment. I'm going to open up Jupyter Notebook and get started. Okay, here I am at the Image Basics Assessment Notebook, and we're going to get started with a couple of imports that we're going to be needing. We'll import CV2, import numpy as NP in case we need that, and then finally, since we know we're going to be displaying images, we'll import matplotlib.pyplot as PLT, and then matplotlib inline. We'll run that, and then we'll read in the image. So we'll read it in with CV2, imread, and what we're going to do here is right now it's in the data folder, so we'll say data, and you should be able to, again, tab autocomplete this if you're doing it correctly, dog backpack. Depending on where you are, you may have to go back up a directory, so say .. /. Again, it all depends on where this notebook actually is and where the data folder actually is. Now, if I were to directly show this with imshow, recall that the order of the colors is going to be wrong. So the blue and red channel are actually now switched. So what we need to do is convert that using the CV2 CVT color function. We're going to come down here and do that. I'm going to say AIMG, red, green, blue, is equal to CV2.CVT color, and we'll take in the original image we read in, and then convert it by using color underscore blue, green, red to red, green, blue. And now we'll display that updated image show, RGB, and when you run that, you should now have this dog in the backpack picture. Keep in mind, I'm really zoomed in, so yours may appear slightly smaller. The next task is to flip the image upside down and display it in the notebook. So the way we can do that is I can really just say new image is equal to image RGB. I can make a copy of it. So I'm going to make a copy and then flip that copy. So we'll say new image is equal to CV2.flip that new image. And the reason I created a new image was just because I didn't want to mess around with this original copy and accidentally flip the original. So if we want to actually flip it upside down, then we pass in 0. So I can say PLT imshow, show that new image, and there is the dog backpack image upside down. The next task was to draw an empty red rectangle around the dog's face and display the image in the notebook. Now, we can just kind of guesstimate where the actual points are. We just need 2 points for the rectangle. So it looks like the start of the dog's face on the top left should be around maybe 250, 400-ish, maybe 200, 380, a little less than 400, maybe a little less than 250. And again, we're just guesstimating here. So I'll say point 1 is equal to the coordinates, and I'm just using the solutions here, but your values may be slightly different. So that's the top left corner, and then point 2 for the bottom right corner. That should be probably around, if I'm just guesstimating here, a little over 500, and then somewhere around 700 for the y. So let's just say 600, 700. So I have my 2 points, the top left corner and the bottom right corner. So what I will do is I will say CV2 rectangle, and then grab my original red, green, blue image, and then say point 1 is equal to point 1, point 2 is equal to point 2. So we're just saying the parameters here that we defined earlier. And then for the color, now that it's been corrected, the red channel is first. So we'll say 255 for red. And then we have green, blue as zeros. And it's up to you whatever thickness you want it to do. You should add some thickness to it, otherwise you won't really be able to see the rectangle. So I'll just say thickness 10. And let's show the results of that. We'll say PLT imshow image red, green, blue. Run that. And now I get to see the rectangle around the dog's face. So that all worked out. Up next, we wanted to draw a blue triangle in the middle of the image. Now the size and angles of the triangle itself is kind of up to you, but probably the easiest to do is an equilateral triangle here, since these bottom points of the triangle are sharing a value here around the y. Let's go ahead and figure out how we can do this. So the first thing we're going to do is set up our vertices. And then we're going to have to choose our points. So in this case, we're going to have 3 sets of points. So let's go ahead and set up those 3 braces. So we'll first go with this first point over here. I would say this point is around 250 and 700. So we'll say 250 along x, 700 along y. And then if we go straight over to this next point, the bottom right point of this triangle, that's actually going to have the same values of 700. So we'll go ahead and fill that in right off the bat, 700. And it's kind of up to you how far along you want to go, but it looks like this one goes around up to 600. So we'll add that one as the point. And then in the middle, this top one, well, that can be basically right in the middle of the image. So for this one, it's kind of up to you, but let's go ahead and say around 425, and then kind of in the middle, it's around 400. Again, lots of different possible answers here. So 425 and then 400, essentially just picking the x and y coordinates of these 3 points. Now, in order to make sure this works, we should be casting this as an integer. So we'll say np int, 32-bit. Sometimes, depending on what version of an operating system you use, if you don't pass in the data type here, you may get an error because it doesn't understand that vertices are floating point numbers. So we'll keep them as integers here. And if we check out our vertices, it's essentially an array that looks like this. But remember that OpenCV is actually quite particular about what format the points should be in. So if we actually check the shape of this, it's 3-2, and that's not the format that OpenCV wants. So we're just going to follow the same recipe that we showed earlier in the lecture. And keep in mind, I don't have these sort of recipes memorized. I basically just reference my own notes here. But we're going to reshape this to -1, 1, 2. And upon doing that, if we check out the vertices, now they're organized with kind of an extra layer of a dimension. So let's now show the points that we reformatted. And there we go. So now we see there's an extra dimension there. And if I check the shape of points, it now has 3 dimensions. It's 3 by 1 by 2. That way it can match up kind of with those color channels. Okay, so we have point shape ready to go. Let's actually now create the polylines. We'll say CV2 polylines, pass in the image we want to draw on, in this case image RGB, and then as a list, pass in the points. Again, kind of another weird quirk of OpenCV. We'll say is closed equal to true, so we actually close that up and connect those points. And then the color, we want it to be blue, so we'll say red is 0, green is 0, and blue is full value 255. And we can go ahead and give this whatever thickness we want. Let's make the triangle pretty thick, that way we can see it easily. And then let's display the result. So we drew that on the image IMG RGB. So when I run that and I scroll down, now I get to see that blue triangle. Keep in mind that red rectangle is actually still there from the previous drawing up here. So if you want to get rid of that, you just need to read in the image file again, or just run this line again. If we scroll all the way back up here, remember we still have this line right here. So if you copy this, scroll down, and then enter it right above that cell, and you rerun this, that basically reads in that original image, fixes the color, and resets the image RGB. So if you look at the solutions notebook, that line is also included there. Okay, so now we have the last bonus task, and it is, can you figure out how to fill in this triangle? So you had to do a little bit of searching, and if you click on this link, it'll take you to the link called Fill Poly, and hopefully you're able to figure out that Fill Poly essentially works the exact same way as polylines, except it will actually fill it out. So notice here, Python CV2 fill poly, the image, the points, the color, essentially telling you what the function should do. So let's come back here and actually then fill that out. So we're going to take essentially what we have up here, copy that, and then paste it here. Except now what we're going to do is instead of polylines, I'm just going to say fill poly, and then the thickness parameter no longer makes sense because we know it's filled in. As well as the isClosed parameter, if you take a look back at the drawing function, fill poly doesn't actually have isClosed because obviously if you're filling it, it intends to be closed. So let's actually try running this and see if this works for us. So if you run that, you should see a filled in blue triangle. Okay, so this last task you may need to run as a script depending on what your operating system is. If you're on a Mac OS or Linux, you probably should run this as a separate script away from this notebook. I'm on Windows right now, so I don't really have those issues, so I'm going to put it all in one cell. This task is to create a script that opens up the picture, this dog backpack picture, and allows you to draw empty red circles wherever you click the right mouse button. So let's go ahead and do our imports here. We'll redo everything just in case you intend running this as a separate script. Import numpy as np, And then we're going to create a function called createCircle. And what this does is it takes in the event, the X and Y location of that particular event, and then flags and parameters. And we want the event to happen when we click the right mouse button. So we'll say if the event was equal to CV2 event, and if you hit tab here, you should be able to find a right mouse button if you start exploring. And in fact, it's right here. It's R button down, just like the last one was L button down for a left mouse button. And then we'll go ahead and add a circle. We'll say CV2 circle image and then X comma Y. And let's go ahead and give this a radius of 100. We want a red, so we'll say 0, 0, 255. Since we're dealing right now with open CV, remember its ordering is blue, green, red. So we'll leave 255 here. And if we want it filled in, we can say -1. If we want a particular thickness, we can say something like thickness is equal to 10. So kind of up to you what you want to do there. I think we said empty red circle, so we'll just say thickness is equal to 10. So there's our create circle, and now we need to set up the connections and open up the image. So we'll say image is equal to, and in this case we'll say CV2 image read, and I'm going to read in from the data the dog backpack image. Previously we were just making our own images with numpy zeros, but I'm just going to read this one in. And remember, we need to create a named window. So window name, let's go ahead and just have it be dog. So that's the same name we're going to assign with the set mouse callback. We'll assign it to dog, and then we'll connect it to our draw circle function. And then finally, let's go ahead and set up the while loop that will continue to display this image. We'll say while true, cv2.imshow will show a window called dog with that image that we read in. And then finally we have our if cv2.waitKey with some arbitrary value, 20 milliseconds, ampersand, and remember it's 0xff is equal to 27, the escape key. Go ahead and break out of that loop. And then finally, just for safety, we'll destroy all the windows. Okay, so very similar to what we did in the past. Basically, the only difference is the event, it's a right button down, and instead of creating our own image using a numpy array, we're actually just reading it in. Let's run this and make sure it works. Looks like we may have draw circles not defined. Oops, I said create circle. So let's go ahead and say create circle. Okay, run that again. It looks like it's running, so let me look down here, see if I have something. So there's a cute dog, and as I click on the right mouse button, there I get to see the empty circles. Okay, so it looks like everything is working. If you have any questions, definitely check out the Solutions Notebook. There's a lot more explanatory comments in it, and feel free to post the Q&A forums. Thanks, and we'll see you at the next section of the course.